Right, welcome to episode 4 of my Lua tutorial. You'll notice I've put in a block of bedrock here, which means that we can't move it, but this was just as part of a demonstration. If you recall last video, I wanted to be able to move this turtle with some very simple commands. So just to give you an example, if I right click on it and I'll clear this, I've written some functions. If I list them, you'll see we've got B, D, F, L, R and U, Lua. Now those are meant to stand for back, down, forward, left, right and up. So that, for example, if I wanted to move the turtle forward by 5 moves, I can go forward 5, press the enter key, it tells me the fuel level, moves the turtle forward, and then tells me that it's moved forward 5 out of 5 places. So all well and good. If I want to move it back, I can go back 5. Now you'll note this time that rather than trying to simply move the turtle back, I rotate it first, then move back, because if there is something in the way, you would need to rotate it to break it anyway. So let's hit that and see what happens. And hopefully we're back where we started from. There we are. So reduce fuel level and move forwards 5 out of 5. There we are. Everything's working nicely. Now the reason I've got the bedrock up there is I'll just show you initially, if I place deliberately a couple of blocks in front of the turtle here, if I ask it to move forward 3 blocks without specifying anything else, it will say move forward 0 out of 3, movement obstructed. So I have one other argument I can add to this. I can say forward 4 or 3, let's say 3, dig. And now it's moving them and it's digging at the same time. Move forwards 3 out of 3, job done. Let's go back 3. And now we're going to try and move up. So if I just do a simple up 1 and hit the enter key, it'll tell me movement obstructed. If I now try and go up with that additional argument that says dig, up 1, dig, it'll say move forward 0, unbreakable block detected. So it's found that it's got bedrock above it. So this is incredibly useful in our programming to look for and know when bedrock exists. The other features I've got there, I've showed you back and forward. I can also do rotate left or right. So if I go right 3, and then I'll have to try and jump out the way quickly and by pressing the escape key. There we go, it's rotated 3 times and it's turned right 3 times. Same with left 4, and it's moved left 4 times. So you've now got quite a bit of control. I could also go down. Let's try D. Let's just go 3 blocks down, and I'll have to put the dig. I can actually just put D. Any argument you put here, I could even put X, it doesn't really matter. The fact I've just supplied an extra letter will dig down 3 times. There we go, he's back, and then we can hopefully rescue it. Up 3. There we are. So for using your turtle in survival mode, this is a very useful set of commands. So today we're going to explore how we can create those commands. So I'll just escape out of here a little bit and reduce the size of my Minecraft window so that, as before, we can get the Notepad++ in there. So I've got an empty one. On the big side, I'll just reduce that a bit. That'll do. Let's start by, I'm going to now move the little programs that I've already built inside that turtle, because I don't want to have that. If I just go here, let's find your. Well, I don't want to overwrite what I've already done here. I want to show you how to make them. So if I just get these out of my computer number 8 here, is if I cut those, and I'm just going to paste them into this level here so that I can put them back when I'm ready. So this is Turtle 8 that we're on now. We've just got the felled tree in there, so we're going to now go back here and create one of those files. So if I clear this first, and then we're going to, let's start with either the turning left or turning right, as they're the easiest. So if I do a new one called L, just call it L, that's for left, and then we'll press the control key, and then we'll save, control key again, exit, there we go. And you'll see that behind the scenes here we've now got, drag this in, L.lua. So that's the one that we want to edit in Notepad++, so we'll just drag that on, and there is our L.lua. I'll get this out of the way so that it doesn't clog our view. Now, when you notice that I was typing in, I typed in the name of the program to run it, which you're familiar with when, for example, we did fell tree here. We did that, but with the movements that I wanted to do, if I let's get rid of that. So we want we're now doing L, so if I just type in L and I wanted to move it 2 times, it will complain at the moment because there's nothing actually in L, so nothing happens. But you notice that 2 that I typed in is an argument, same as we supplied to our functions in the last one. So we are now going to send an argument to the program when it runs, and the Computercraft has a particular way of dealing with that, is that you have to create a variable. The sensible one would be to call it args equals, and then inside curly brackets you put 3 dots, close the curly brackets. So this is peculiar to the Computercraft and the way that Lua works here, is that the arguments here is a table, which is what these curly brackets represent, with kind of placeholders in there, so that you can send as many arguments as you like over here on this screen and they will fill up this table. Now, just a brief word about tables. If you have studied Python or any other programming language, you'll be used to simple variables like strings and lists and strings and numbers. You may also have come across lists where you have perhaps several variables listed together, and then you may have dictionaries, structs, and all kinds of things. I don't want to get too heavily involved in that, but Lua doesn't have any of those. It has instead a table, and the table is a very clever piece of kit, and we will be exploring that in far greater detail as we go along. But for the time being, we'll just accept that this data type called a table will hold basically whatever information we want it to. So that will hold the information that we want to. Now, it has to be done not in any kind of function, so that has to be put straight into the top of the script there. If you put it anywhere else, you get an error. So that will read in what we're using. So as before, we want a function main. So we'll put that in before we do anything. End the function, of course, and then call it. So standard procedure. This is an empty project. It's not doing anything at the moment, but it's got everything set up and ready to go. Now, what we want to do is to ask the turtle to turn, in this case because we called it L, we want the turtle to turn left as many times as we've asked for. But it's just possible that I might have in here, instead of giving it an argument, I might have just said L and then pressed the enter key. It didn't crash, which is great, but we've kind of forgot to give it any arguments. So we have to take account of what I would call user stupidity. So the user didn't put a number in, so we have to give it a default one. So we are going to create a variable in here, and we use the local again because this variable is going to only exist within the main function. It's not global so that the whole program can see it. Unlike args, the whole program can see this, but we're just going to have a local one, and we'll call it num turns. That seems to be a good name for a and we'll call it as 0. So we'll set it to 0 by default so that it won't do anything if we don't send it to. Now we need to find out what has been supplied in those arguments. Now if, as I did here, I type in L and no arguments and just hit the enter key, then that table will be empty. So we can check for that. So if we go if args 1, which is the way tables work. If you've used lists in Python or other languages, you'll know that you can use these square brackets with a number inside, which is the index of the list. Now Lua lists start with an index of 1, not 0. So if you're used to having a list starting at 0, it's not in Lua, it always starts at 1. So what we're checking for is if we had supplied, for example here, if we'd supplied, I'll just put this in as a comment, user typed L3, okay, that's meant to be lowercase L3. The arguments supplied were just 3, so those 3 dots would represent just a simple 3, and that would have been in this args1. So if args1 here, what we're checking for is not if it's equal to anything, but if it's not equal to anything. So the way not equals is represented in Lua is the tilde key plus equals. In other languages it's the exclamation, so that's C#. Believe it's the same in Python, I can't remember offhand, but in Lua it's this tilde key, so that means not equal. So if arg1 does not equal nil, now nil means it has no value whatsoever. There's no, it hasn't been given an empty string, it's not 0, it's just nothing, it doesn't exist. So if it doesn't exist, then we're going to give our num turns a value. So we'll leave that for the moment. So if it's not equal to nil, I'll put an else in here ready for dealing with that. But at the moment we're just going to say that if the arguments here are not nil, in other words we've got some kind of number in here, then we can deal with that now. So let's say we put 3 in. Now that means that we want to turn the turtle 3 times. So let's do that. We can use, if you recall, if we know that we want to run a loop 3 times or a fixed number of times, we use a for loop. That's just what we discovered last time. For I equals 1 comma, so we're going to start off at 1, but how many times do we run it? Well, we want the value of args1, so we can put that in there again. Simple thing to do there is control copy, control V. So if that contains 3, then that's great. Do. Let's end our for loop, and inside the for loop there we want to turn the turtle a specific number of turns. Now I could just say turtle dot turn left, like that, which would work. It'll turn it left, run 3 times, turn it left 3 times. But what I wanted to do was to inform the user afterwards how many times we've moved it. So that's why I set up this little local variable here. So initially number of turns is set to 0. So again, if you remember, turnLeft will return either a true or a false value. I can't see any reason why it would ever return false, because the turtle doesn't need fuel to turn left and right, and also there's nothing in the way to stop it. So it will always do this, but just to stick with convention, we will put if turtle turn left, then and end, and then we will not want to increase the value of num turns. So the only way to do this in Lua is to do it this way: equals +1. So what you're doing is you're taking the variable num turns, which currently has the value 0 in it, and you're now going to reassign it a new value, and the new value will be what the current value is +1. So if you forget to do that, it will always make it whatever this is, so it'll always be 1. Whereas if you do it this way, it starts off at 0. The first time the loop runs, that will have 1 added to it, so that will turn into 1. The second time this runs, that will have a 2 in it, then you add another 1, and so on. So this will always increase. In other languages you have, I'll show you here, num turns plus equals, out of the way, but it doesn't work in Lua. You'd have, sorry, plus equals 1 or plus plus, which are the ways of doing it in other languages. So let me take that out of the way. It doesn't work in Lua. You have to do it this full way: num turns equals num turns plus 1. So that has now increased the value. Let me just sit that on back. It's not lining up properly. I don't like it when it does that, so we'll just shift, that's better. There's absolutely no reason to do this apart from it irritates me if everything is not nicely lined up in the tab spaces, but the code will run perfectly. So what this is doing now is we typed in L3, and the function main which we're running from here will then say local number of turns is 0 if args1, which is the 3, does not equal nil, which it doesn't because it's equal to 3. Then we're going to run this for loop for 1 equals 1, and of course in this case 3, so it's going to run 3 times. Turtle turn left and then increase the number in there. So that's done our little bit there. Now if we didn't specify an arg, we're just going to use the fact that we're going to do it, say, once. So let's put that in, because you wouldn't really call this if you had no intention of turning it at all, would you? So we'll do something similar, and we'll copy that and we'll put it in here. Again, we'll just tidy those up, and then we're just going to say that num turns equals 1. So let's just go through that again, and if we've typed in left 3 times, and we forgot to put, sorry, we typed in left without L, just as I did here, this L. So args1 is equal to nil, so it ignores that, and then if turtle.turn left, then num turns equals 1, end. So we've now turned it once because we didn't supply a value, so we're using the default of 1 turn. Now we want to print that out onto our console. So if we go print, and we can put a message turned left space. Now what we want to do now is to add how many times we turned. Now in Python and C# and other language you would put plus, and then you would say num turns, and then you would put plus turns to make up the output. If you try to do this in Lua, if that is not a number, and that is not a number, and that is a number, the whole lot's going to crash out because it will say it can't concatenate strings and all kinds of nonsense. So Lua has a far nicer method, which is the double dot. This is the string concatenation symbol. This really ought to be put into all other programming languages, because it stops all this nonsense you get with Python when you're trying to join numbers and strings, which Python doesn't inherently tell you what you've got until you try and run it, and then it errors because you're trying to add 1 to turnLeft. This one simply takes what is a genuine number and concatenates it, joins it to the strings that you've put here, turnLeft, turns. So let me just leave that, check that over. I think that will work. Yep, that's fine. So let's try it. So we can save that. Now the original version of left that I had in here is gone, if you remember. I deleted it. This is our brand new version. So let's try it and see if it crashes out. So I'll just put initially 1L and we'll press the enter key. turnLeft 1 turns. Look at that. So if we escape from there, yep, we're there. Now we're going to try it 2 times. So we'll go L. Let's try it 3 times and then press enter. See if I can hit the escape key. There we are. It's working. So that's how I just escaped from that. That's how we can get the turtle to move by entering some commands here. Now obviously we also want to perhaps do this for turnRight, so I'll just show you a kind of a quick way of doing this. If we now go and get the thing, there's our l.lua. If I copy that and paste it, obviously it comes out with l copy.lua. We're going to rename that as r.lua. Now, so we've got exactly the same file inside. So I will shut this one off. We finish with l.lua. This is now r.lua. And basically what we want to do is to change our turtle turnLeft to turtle turnRight. Just make sure we got it down here again. So exactly the same, let me just change this one as well, exactly the same code, except we've just changed the direction in which it turned and the text that tells it. We'll save that now. So now we've got an r.lua and an l.lua. So if we go back to here, escape from that and have a look, let's clear this. List by pressing ls, enter, we've got fell tree, l.lua and r.lua. So a moment ago we did left. Let's try r3, and again I'll press the escape key as soon as I hit enter, and it's turned right 3 times. So we've now got a turn right and a turn left, so that's absolutely perfect. Next thing I think would be useful to explore would be perhaps a forward one. So if I right click on this, we're going to edit F, which is short for forward, and then we'll control and save, press enter, control and exit. There we go. So we've now got an f.lua. Let me get rid of that, and we'll put f.lua in there, which of course is a completely empty file. So f.lua, let's start with borrowing some of the code we've already put in here. So for example, we can take all of that, Control C. Again, I'm showing you how lazy we programmers are. We don't want to type all this lot out again. Control V, and then what we're going to do is to get rid of that. So we've now got our basic structure again. Now this time we might want to type in forward 3. Now if you remember on when I was showing you a moment ago, I could also add something like dig. So I'm supplying it this time either with just a number or with a number and an instruction to dig in case there are blocks in the way. So this is going to be a little bit more complex to do, and we'll cover that in the next video.